Hey, welcome everyone. My name is Freitas. I'm a junior in Mather studying computer science with a focus in computational linguistics. So my secondary is in language and linguistic theory. I'm really excited to teach you guys a little bit about the field. It's a very exciting area to study, also with a lot of potential for the future. So I'm really excited that you guys are considering projects in computational linguistics, and I'll be more than happy to advise any of you if you decide to pursue one of those. So first of all, what are computational linguistics? So computational linguistics is the intersection between linguistics and computer science. So what is linguistics? What is computer science? Well, from linguistics, what we take are the languages. So linguistics is actually the study of natural language in general. So natural language, we talk about language that we actually use to communicate with each other. So we're not exactly talking about like C or Java. We're talking more about English and Chinese and other languages that we use to communicate with each other. The challenging thing about that is that right now we have almost 7,000 languages in the world. So there are quite a high variety of languages that we can study. And then you think that it's probably very hard to do, for example, translation from one language to the other, considering that you have almost 7,000 of them. So if you think of doing translation from one language to the other, you have almost more than 1 million different combinations that you can have from language to language. So it's really challenging to do some kind of, for example, translation system for every single language. So linguistics treats with syntax, semantics, pragmatics. You guys don't exactly need to know what they are. But the very interesting thing is that as a native speaker, when you learn language as a child, you actually learn all of those things, syntax, semantics, and pragmatics, by yourself. Nobody has to teach you syntax for you to understand how a sentence is structured. So it's really interesting because it's something that comes very intuitively. And what are you taking from the computer science? Well, the most important thing that we have in the computer science is, first of all, artificial intelligence and machine learning. So what we're trying to do in computational linguistics is teach your computer pretty much how to do something with language. So for example, in machine translation, I'm trying to teach my computer how to know how to transition from one language to the other. So basically like teaching your computer 2 languages. If I do natural language processing, which is the case, for example, of Facebook's graph search, you're teaching your computer how to understand queries well. So if you say the photos of my friends, Facebook doesn't treat that as a whole string that has just a bunch of words. It actually understands the relation between photos and my friends, and understands that the photos are property of my friends. So that's part of, for example, natural language processing. It's trying to understand what is the relation between the words in a sentence. And the big question is, can you teach a computer how to speak a language in general? Which is a very interesting question to think, as if maybe in the future you're going to be able to talk to your cell phone, kind of like what we do with Siri, but something more like you can actually say whatever you want, the phone is going to understand everything, and you can have follow-up questions and keep talking. That's something really exciting in my opinion. So something about natural languages. Something really interesting about natural languages is that, and this is credit to my linguistics professor, Maria Polinsky. She gives this example, and I think it's really interesting, because we learn language from when we're born, and then our native language kind of grows on us. And basically, you learn language from minimal input, right? You're just getting input from your parents as what language your language sounds like, and you just learn it. So it's interesting because if you look at the sentences, for example, you look, Mary puts on a coat every time she leaves the house. You know that in this case, it's possible to have the word she refer to Mary, right? You can say Mary puts on a coat every time Mary leaves the house. So that's fine. But then if you look at the sentence, she puts on a coat every time Mary leaves the house, you know it's impossible to say that she is referring to Mary. There's no way of saying that Mary puts on a coat every time Mary leaves the house. So it's interesting because this is the kind of intuition that every native speaker has. And nobody was taught that this is the way that the syntax works, and that you can only have this she referring to Mary in this first case, and actually in this other 2, but not in this one. But everyone kind of gets to the same answer. Everyone agrees on that. So it's really interesting how, although you're not, you don't know all the rules in your language, you kind of understand how the language works. So the interesting things about natural language is that you don't have to know any syntax to know how, if a sentence is grammatical or ungrammatical for most cases. which makes you think that maybe what happens is that through your life, you just keep getting more and more sentences like told to you, and then you keep like memorizing all of the sentences, and then when someone tells you something, you hear that sentence and kind of like you look at your vocabulary of sentences and you see if that sentence is there. And if it is there, you say it's grammatical. If it's not, you say it's ungrammatical. So in that case, you would say, oh, so you have like a huge list of all possible sentences, and then when you hear a sentence, you know if it's grammatical or not based on that. The thing is that if you look at a sentence, for example, the 5-headed CS50TFs coached the blind octopus using a DAPA mug, it's definitely not a sentence that you heard before, but at the same time, you know it's pretty much grammatical, right? There are no like grammatical mistakes, and you can say that it's a possible sentence. So it makes us think that actually the way that we learn language is not only by having a huge database of possible words or sentences, but more of like understanding the relation between words in those sentences. Does that make sense? So then the question is, how can computers learn languages? Can we teach languages to computers? So let's think of the difference between a native speaker of a language and a computer. So what happens to the native speaker? Well, the native speaker learns a language from exposure to it. Usually it's early childhood years. So basically you just have a baby and you keep talking to it and it just learns how to speak the language, right? So you're basically giving input to the baby. So then you can argument that a computer can do the same thing, right? You can just give language as input to the computer. As for example, a bunch of files that have like books in English maybe, that's one way that you could like possibly like teach your computer English, right? And in fact, if you think about it, it takes you maybe like a couple days to read a book. For a computer, it takes a second to like look at all the words in a book. So you can think that maybe just this argument of input from around you, that's like not enough to say that that's something that only humans can do. You can think that computers also can get input. The second thing is that native speakers also have a brain that has language learning capability. But if you think about it, a brain is like a solid thing. Like when you are born, it's already like set as like this is your brain. And as you grow up, you just get more input of language and maybe like nutrients and other stuff. But pretty much your brain is like a solid thing. So you can say, well, maybe you can like build a computer that has a bunch of functions and methods that just mimic language learning capability. So in that sense, you could say, well, I can like have a computer that has all the things I need to learn language. And the last thing is that a native speaker learns from trial and error. So basically, another important thing in language learning is that you kind of learn things by making generalizations of what you hear. So as you are growing up, you learn that some words are more like nouns, some other ones are adjectives, and you don't have to have any knowledge of linguistics to understand that, but you just know that some words are positioned in some part of the sentence and some others are in other part of the sentence. And when you do something that is like a sentence that is not correct, maybe because of an overgeneralization, for example, maybe like when you're growing up, you notice that plural is usually formed by putting an S at the end of the sentence, at the end of the word, and then you try to like do the plural of deer as deers, or like tooth as tooths. So then your parents or like someone corrects you and say, no, the plural of deer is deer, and the plural of tooth is teeth, and then you learn those things. So you learn from trial and error. But you can also do that with a computer. You can have something called reinforcement learning, which is basically like giving your computer a reward whenever it does something correctly, and like giving it the opposite of a reward when it does something wrong. You can actually see that if you go to Google Translate and you try to translate a sentence, it asks you for feedback. So if you say, oh, there's like a better translation for this sentence, you can type it up. And then if a lot of people like keep like saying that is like a better translation, it just learns that you should like use that translation instead of the one it was giving. So it's a very like philosophical question to say like computers can talk or not, like are going to be able to talk or not in the future. But I have like high hopes that they can, just based on like those arguments. But it's just more of like a philosophical question. So why computers still cannot talk? What are the things that we can do? Some really cool things are data classification. So for example, you guys know that email services do, for example, spam filtering. So whenever you receive spam, it tries to filter to another box. So how does it do that? It's not like the computer just knows what kind of email addresses are sending spam. So it's more based on the content of the message, or maybe the title, or maybe some pattern that you have. So basically what you can do is get a lot of data of emails that are spam, emails that are not spam, and kind of learn like what kind of patterns that you have in the ones that are spam. And this is part of computational linguistics. It's called data classification. And we're actually going to see an example of that in the next slides. The second thing is natural language processing, which is the thing that the graph search is doing, of like letting you write a sentence and it tries to understand what is the meaning and give you a better result. Actually, if you go to Google or Bing and you search something like, I don't know, Lady Gaga's height, you're actually going to get 5'1" instead of like information from her, because it actually understands what you're talking about. So that's part of natural language processing. Or also when you're using Siri, first you have an algorithm that tries to translate what you're saying into words, like in text, and then it tries to translate that into meaning. So that's all part of natural language processing. Then you have machine translation, which is actually like one of my favorites, which is just translating from a language to another. So you can think that when you're doing machine translation, you have infinite possibilities of sentences, so there's no way of just storing every single translation. So you have to come up with interesting algorithms to be able to translate every single sentence in some way. You guys have any questions so far? No? Okay, so what are we going to see today? First of all, I'm going to talk about the classification problem, so the one that I was saying about spam. But what I'm going to do is, giving lyrics to a song, can you try to figure out with high probability who is the singer? If it's like, let's say that I have songs from like Lady Gaga and Katy Perry. If I give you a new song, can you figure out if it's Katy Perry or Lady Gaga? The second one, I'm just going to talk about the segmentation problem. So I don't know if you guys know, but Chinese, Japanese, other East Asian languages, and other languages in general don't have spaces between words. And then if you think about the way that your computer kind of tries to understand natural language processing, it kind of looks at the words and tries to understand the relations between them, right? But then if you have Chinese and you have 0 spaces, it's really hard to like kind of find out like what is the relation between words, because you don't have any words at first. So you have to do something called segmentation, which just means like putting spaces between what we call words in those languages. Make sense? And then we're going to talk about syntax, so just a little bit about natural language processing. This is going to be just an overview. So today, basically, what I want to do is more like give you guys a little bit of an insight of what are the possibilities that you can do with computational linguistics. And then you can like see what you think is cool among those things, and maybe you can think of a project and come talk to me, and I can give you advice on how to implement it. So syntax is going to be a little bit about graph search. And machine translation, I'm just going to give an example of how you could, for example, translate something from Portuguese to English. Sounds good? So first, the classification problem. I would say that this part of the seminar is going to be the most challenging one, just because there's going to be some coding. But it's going to be Python. I know you guys don't know Python, so I'm just going to like explain like kind of like on the high level what I'm doing, and you don't have to really care too much about the syntax, because that's something you guys can learn. Okay, sounds good? So what is the classification problem? So you're giving some lyrics to a song, and you want to guess who is singing it. And this can be for like any kind of other problems. So it can be, for example, you have a presidential campaign, and you want to find out if you have like a speech, and you want to find out if it was, for example, Obama or Mitt Romney. Or you can have a bunch of emails and you want to figure out if they're spam or not. So it's just classifying some data based on the words that you have there. So to do that, you have to make some assumptions. So a lot about computational linguistics is making assumptions, usually smart assumptions, so that you can get good results. Trying to like create a model for it, and then try it out and see if it works, if it gives you good precision. And if it does, then you like try to like improve it. If it doesn't, you're like, okay, maybe I should make a different assumption. So the assumption that you're going to make is that an artist like usually sings about a topic like multiple times, and maybe uses words multiple times just because they're used to it. You can just think of your friend. I'm sure you guys all have friends that say like their signature phrase like literally like for every single sentence, like some specific word or some specific phrase that they say for every single sentence. And what you can say is that if you see like a sentence that has a signature phrase, you can kind of guess that probably your friend is the one saying it, right? So, so you make that assumption, and then that's how you create a model. The example that I'm going to give is on how Lady Gaga, for example, people say that she uses baby for all her #1 songs. And actually, like, this is like a video that shows like her like saying the word baby for different songs, and it's kind of. So there are like, I think 40 songs here in which it says the word baby. So you can basically like kind of like guess that if you see a song that has the word baby, like there's like some high probability that it's Lady Gaga. But let's try to like develop this further and like more formally. So these are lyrics to songs by Lady Gaga and Katy Perry. So you look at Lady Gaga, you see that you have a lot of occurrences of baby, a lot of occurrences of way. And then Katy Perry, you have a lot of occurrences of a lot of occurrences of fire. So basically, what we want to do is you get a lyric. Let's say that you get a lyric like for a song that is baby, just baby. If you just get the word baby, and this is all the data that you have from Lady Gaga and Katy Perry, who would you guess is the person who sings the song? Lady Gaga or Katy Perry? Lady Gaga, right? Because she's the only one who says baby. This sounds like stupid, right? Okay, this is really easy. I'm just looking at the two songs, and of course, she's the only one who has baby. But what if you have a bunch of words? If you have like an actual lyric, like something like, I don't know, baby, I just went to see a safety lecture, or something like that, and then you actually have to figure out, based on all those words, who is the artist who probably sang the song. So let's try to develop this a little further. Okay, so based on just on the data that we got, it seems that Gaga is probably the singer, but how can we write this more formally? So what I'm trying to calculate actually, and this is going to be a little bit of statistics, so if you get lost, just try to like understand the concept. Doesn't matter if you like understand the equations perfectly well. This is all going to be online. So basically what I'm calculating is the probability that this song is by Lady Gaga, given that, so this bar means given that I saw the word baby. Does that make sense? So I'm trying to calculate that probability. So there is this theorem called the Bayes theorem that says that probability of like A given B is probability of B given A times probability of A over the probability of B. This is a long equation, but what you have to understand from that is that this is what I want to calculate, right? So the probability that song is by Lady Gaga, given that I saw the word baby. And now what I'm getting is the probability of the word baby, given that I have Lady Gaga. And what is that basically? That basically means what is the probability of seeing the word baby in Gaga lyrics? If I want to calculate that in a very simple way, it's just the number of times I see baby over the total number of words in Gaga lyrics, right? It's just like what is the frequency that I see that word in Gaga's work? Make sense? The second term is the probability of Gaga. What does that mean? That basically means that what is the probability of classifying some lyrics as Gaga? And like that is kind of weird, but like let's think of an example. So let's say that the probability of having baby in a song is the same for Gaga and Britney Spears. But Britney Spears has twice more songs than Lady Gaga. So if someone just randomly gives you lyrics of like being baby, the first thing you look is what is the probability of having baby in a Gaga song, baby in a Britney song, and it's the same thing. So the second thing that you see is, well, what is the probability of this lyric by itself being a Gaga lyric, and what is the probability of being a Britney lyric? So since Britney has so many more lyrics than Gaga, you would probably say, well, this is probably a Britney lyric. So that's why we have this term right here, probability of Gaga. Make sense? Does it? Okay. And the last one is just the probability of baby, which is doesn't really matter that much, but it's just like the probability of seeing baby like in English, kind of. But like we usually don't care that much about that term. Does that make sense? So probability of Gaga is called the prior probability of the class Gaga because it just means that what is the probability of having that class, which is Gaga, like just in general, just like with no conditions. And then when I have probability of Gaga given baby, we call it posterior probability because it's the probability of having Gaga giving some evidence. So I'm giving you the evidence that I saw the word baby in the song. Make sense? Okay, so if I calculated that for each of the songs, for Lady Gaga, what we'll get would be, oops, apparently I cannot move this. The probability of Gaga will be like something like 2 over 24 times a half over 2 over 53. Doesn't matter if you like know what these numbers are coming from, but it's just like a number that is going to be like more than 0, right? And then when I do Katy Perry, like the probability of baby given Katy is already 0, right? Because there's no baby in Katy Perry. So then this becomes 0, and Gaga wins, which means that Gaga is probably the singer. Does that make sense? Okay. So then we have, so if I want to like make this more official, I can actually like do like a model for multiple words. So let's say that I have something like baby, I am on fire or something. So it has multiple words. And in this case, you can see that baby is in Gaga, but it's not in Katy, and fire is in Katy, but it's not in Gaga, right? So it's kind of like, it's getting trickier, right? Because it seems that you kind of almost have a tie between the two. So what you have to do is assume independency between among the words. So basically what that means is that I'm just calculating what is the probability of seeing baby, what is the probability of seeing I, and am, and on, and fire, all separately. Then I'm multiplying all of them, and I'm seeing what is the probability of seeing the whole sentence. Make sense? So basically, if I have just one word, what I want to find is the Argmax, which means what is the class that is giving me the highest probability. So like, what is the class that is giving me the highest probability for probability of class given word? So in this case, like Gaga given baby or Katy given baby. Make sense? And this will be just from Bayes, the equation that I showed. We create this, this fraction. The only thing is that you see that the probability of word given the class changes depending on the class, right? The number of babies that I have in Gaga is different from Katy. The probability of the class also changes because it's just like the number of songs like each of them has. But the probability of the word itself is going to be the same for all the artists, right? So the probability of the word is just what is the probability of seeing that word in the English language. So it's the same for all of them. So since this is constant, we can just drop this and not care about it. So this will be actually like the equation we're looking for. And if I have multiple words, I'm still going to have the prior probability here. The only thing is that I'm multiplying the probability of all the other words. So I'm multiplying all of them. Make sense? It's kind of, it looks weird, but basically means calculate the prior of the class and then multiply it by the probability of each of the words being in that class. And you know that the probability of a word giving a class is going to be the number of times you see that word in that class divided by the number of words you have in that class in general. Make sense? It's just like how baby was like 2 over the number of words that I had in the lyrics. So just the frequency. But there is one thing. Remember how I was like showing that the probability of baby being lyrics from Katy Perry was 0, just because Katy Perry didn't have baby at all? But it sounds a little harsh to just simply say that a sentence, that like lyrics cannot be from an artist just because they don't have that word in particular at any time. So you could just like say, well, if you don't have this word, I'm going to give you a lower probability, but I'm just not going to like give you 0 right away. Because maybe it was something like fire, 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 which is like totally Katy Perry, and then baby, and then it just like goes to 0 just right away because there was one baby. So basically what we do is something called Laplace smoothing, and this just means that I'm giving some probability even to the words that do not exist. So what I do is that when I'm calculating this, I always add 1 to the numerator. So even if the word doesn't exist, in this case, if this is 0, I'm still calculating this as like 1 over the total number of words. Otherwise, I get how many words I have, and I add 1. So I'm like counting for both cases. Make sense? So now let's do some coding. I'm going to have to do it like pretty fast, but I'm just important that you guys like understand the concepts. So what we're trying to do is exactly implement this thing that I just said. I want you to put lyrics from Lady Gaga and Katy Perry, and you guys are going to be able, and the program is going to be able to say if these new lyrics are from Gaga or Katy Perry. Make sense? Okay. So I have this program. I'm going to call classify.py. So this is Python. It's a new programming language. It is very similar in some ways to C and PHP. It's similar like because, I mean, if you want to learn Python after knowing C, it's really not that much of a challenge just because Python is much easier than C, first of all. And a lot of things are already implemented for you. So just how like PHP has functions that sort a list or like, I don't know, append something to an array or blah, blah, blah. Python has all of those as well. So I'm just going to like explain like quickly like how we could do the classification problem for here. So let's say that in this case I have lyrics from Gaga and Katy Perry. The way that I have those lyrics is that the first word of the lyrics is the name of the artist, and the rest is the lyrics. So let's say that I have this list in which the first one is like lyrics by Gaga. So here I am on the right track, blah, blah, blah. And the next one is Katy, and it has also the lyrics. So this is how you declare a variable in Python. You don't have to like give the data type. You just write lyrics, kind of like in PHP. Make sense? So what are the things that I have to calculate to be able to calculate the probabilities? I have to calculate the priors of each of the different classes that I have. I have to calculate the posteriors, or like pretty much like the probabilities of each of the different words that I can have for like each artist. So like within Gaga, for example, I'm going to have a list of like how many times I see each of the words. Make sense? And finally, I'm just going to have a list called words that is just going to have how many words I have for each artist. So like for Gaga, for example, when I looked at the lyrics, I had, I think, 24 words in total. So this list is just going to have like Gaga, 24, and like Katy, another number. Make sense? OK, so now actually let's go to the coding. So in Python, you can actually like return a bunch of different things from a function. So I'm going to create this function called conditional, which is going to return all of those things, the priors, the probabilities, and the words. So conditional, and it's going to be like calling into lyrics. OK. So now I want to actually write this function. So the way that I can write this function is I just defined the function with def. So I did def conditional, and it's taking lyrics. And what this is going to do is, first of all, I have my priors that I want to calculate. So the way that I can do this is create a dictionary in Python, which is pretty much the same thing as a hash table or as like an iterative array in PHP. So this is how I declare a dictionary. And basically what this means is that priors of like Gaga is like 0.5, for example, if like 50% of the lyrics are from Gaga, 50% are from Katy. Make sense? So how can I calculate so I have to like figure out how I can calculate the priors. The next ones that I have to do also are the probabilities and the words. So probabilities is going to be something like the probabilities of Gaga is like the list of all the probabilities that I have for each of the words for Gaga. So if I go to probabilities of Gaga baby, for example, you'll give me something like 2/24 in that case. Make sense? So I go to probabilities, go to the Gaga bucket that has a list of all the Gaga words. Then I go to baby and I see the probability. And finally, I have this words dictionary. So here, probabilities. And then words. So if I do words Gaga, what is going to happen is that it's going to give me 24, saying that I have 24 words within lyrics from Gaga. Make sense? So here words equals da-da-da. Okay, so what I'm going to do is I'm going to iterate over each of the lyrics, so each of the strings that I have in the list, and I'm going to calculate those things for each of the candidates. Make sense? So I have to do a for loop. So in Python, what I can do is for line in lyrics, the same thing as a for each statement in PHP. Remember how I could do in, if it was PHP, I could say for each lyrics as line. Make sense? So I'm taking each of the lines, in this case, this string and the next string. So for each of the lines, what I'm going to do is first, I'm going to split this line into a list of words separated by spaces. So the cool thing about Python is that you can just Google, like, how can I split a string into words, and it's going to tell you how to do it. And the way to do it, it's just a line equals line.split. It's basically going to give you a list with each of the words here. Make sense? So now that I did that, I want to like know who is the singer of that song. And to do that, I just have to get the first element of the array, right? So I can just say that singer equals line 0. Make sense? And then I can then what I need to do is, first of all, I'm going to update how many words I have under Gaga. So I'm just going to calculate how many words I have in this list, right? Because these are how many words I have in the lyrics. And then I'm just going to add it to the Gaga array. Does that make sense? Don't like focus too much on like the syntax. Think more about like the concepts. That's the most important part. Okay, so what I can do is, if Gaga is already in that list, so if singer in words, which means that I already have words by Gaga, I just want to add the additional words to that. So what I do is words singer equals plus equals, and then I can just do the length of the line, so how many elements I have in the array. And I have to do -1, just because the first element of the array is just a singer, and those are not lyrics. Make sense? Okay. Else, it means that I want to actually insert Gaga into the list. So I just do word singer equals landline. -1, sorry. So the only difference between the two lines is that this one, it doesn't exist yet, so I'm just initializing it. This one I'm actually adding. Okay? So this was adding to words. Now I want to add to the priors. So how do I calculate the priors? The priors can be calculated by how many times, so how many times you see that singer among all of the singers that you have, right? So for Gaga and Katy Perry in this case, I see Gaga once, Katy Perry once. So basically the priors for Gaga and for Katy Perry would just be 1, right? It's just how many times I see the artist. So this is like very easy to calculate. I can just do something similar as like if singer in priors, I'm just gonna add 1 to their priors box. So priors singer plus equals 1. And then else, I'm going to do priors singer equals 1. Make sense? So if it doesn't exist, I just put as 1. Otherwise, I just add 1. Okay. So now all that I have left to do is also add each of the words to the probabilities. So I have to count how many times I see each of the words. So I just have to do another for loop in the line. So first thing that I'm going to do is check if the singer already has a probabilities array. So I'm checking if the singer doesn't have a probabilities array, I'm just going to initialize one for them. In this case, not even an array, sorry, it's a dictionary. So the probabilities of singer is going to be an open dictionary. So I'm just initializing a dictionary for it. Okay. And now I can actually do a for loop to calculate each of the words probabilities. Okay. So what I can do is a for loop. So I'm just going to iterate over the array. So the way that I can do that in Python is for I in range from 1, because I want to start in the second element because the first one is the singer name. So from 1 up to the length of the line. And when I do range, it actually goes from like here from 1 to length of the line -1. So it already does that thing of doing n-1 for arrays, which is very convenient. Make sense? So for each of these, what I'm going to do is, just like in the other ones, I'm going to check if the word in this position in the line is already in probabilities. And then, as I said here, probabilities works as in I put probability singer, so the name of the singer. So if it's already in probability singer, means that I want to add 1 to it. So I'm going to do probabilities singer, and the word is called line I. I'm going to add 1, and else I'm just going to initialize it to 1. And then line. Make sense? So I calculated all of the arrays. So now all that I have to do for this one is just return priors, probabilities, and words. Let's see if there are any. Okay. Seems that everything is working so far. So did that make sense in some way? Okay. So now I have all the probabilities. So now the only thing I have left is just have that thing that calculates the product of all the probabilities when I get the lyrics. So let's say that I want to now call this function classify, and the thing that the function takes is just an argument. Let's say, baby, I am on fire, and it's going to figure out like what is the probability that this is Gaga, what is the probability that this is Katie. Sounds good? So I'm just going to have to create a new function called classify, and it's going to take some lyrics as well. And besides the lyrics, I also have to send the priors, the probabilities, and the words. So I'm going to send lyrics, priors, probabilities, words. So this is taking lyrics, priors, probabilities, words. So what does it do? It basically going to go through all the possible candidates that you have as a singer. And where are those candidates? They're in the priors, right? So I have all of those there. So I'm going to have a dictionary of all possible candidates. And then for each candidate in the priors, so it means that it's going to be Gaga, Katie. If I had more, it'd be more. I'm going to start calculating this probability. The probability, as we saw in the PowerPoint, is the prior times the product of each of the other probabilities. So I can do the same here. I can just do probability is initially just the prior. So priors of the candidate, right? And I have to iterate over all the words that I have in the lyrics to be able to add the probability for each of them. Okay? So for word in lyrics, what I'm going to do is, if the word is in probabilities candidate, which means that it's a word that the candidate has in their lyrics, for example, baby for Gaga, what I'm going to do is that the probability is going to be multiplied by 1 plus the probabilities of the candidate for that word, and it's called word. This divided by the number of words that I have for that candidate, the total number of words that I have for the singer that I'm looking at. Else, it means it's a new word, so it would be like, for example, fire for Lady Gaga. So I just want to do 1 over word candidate. So I don't want to put this term here. So it's going to be basically copying and pasting this. Oops. But I'm going to delete this part. So it's just going to be 1 over that. Sounds good? And now, at the end, I'm just going to print the name of the candidate and the probability that you have of having that as their lyrics. Make sense? And I actually don't even need this dictionary. Make sense? So let's see if this actually works. So if I run this, it didn't work. Wait 1 second. Word candidate. Oh, sorry, words candidate, words candidate. That's the name of the array. Okay. So it says there is some bug for candidate in priors. Let me just cheat a little bit. Okay. Let's try. Okay, so it gives Katy Perry has this probability of like this times 10 to the minus 7, and Gaga has this times 10 to the minus 6. So it shows that Gaga has a higher probability. So Baby, I Am on Fire is probably a Gaga song. Make sense? So this is what we did. This code is going to be posted online, so you guys can like check it out, like maybe like use some of it for like if you want to do like a project or something similar. Okay. This was just like to give like a show like what a computational linguistics code looks like kinda. But now let's go to more high level stuff. Okay, so the other problems I was talking about, the segmentation problem is the first of them. So you have here Japanese, and then you see that there are no spaces. So this basically means that it's like the top of the chair, right? You speak Japanese? It's like the top of the chair, right?
I don't know what the kanji is.
It's like it's no ueda. Okay. So basically means chair of top. So like if you had to put space, it would be here. And then you have Ueda-san, which basically means Mr. Ueda. And you see that Ueda, and like you have a space and then san. So you see that here Ue is like by itself, and here has like a character next to it. So it's not like in those languages characters mean a word, so you just put like a lot of spaces. Like characters like relate to each other, and they can be like together is like 2, 3, 1. So you actually have to like create some kind of way of putting those spaces. And the thing is that whenever you get data from those East Asian languages, everything comes unsegmented, because no one who's like writes like Japanese or Chinese writes with spaces. Like whenever you write in Chinese or Japanese, you just write everything in no spaces. It doesn't even make sense to put spaces. So then when you get data from, I don't know, some like East Asian language, if you want to actually do something with it, you have to segment it first. Think of doing the example of the lyrics without spaces. So the only lyrics that you have will be sentences, right? Like separated by periods. But then like having just the sentence would not really help on like giving you information of those lyrics are by, right? So you should put spaces first. So how can you do that? So then it comes the idea of a language model, which is something really important for computational linguistics. So a language model is basically a table of probabilities that shows first of all, what is the probability of having the word in a language? So showing how frequent a word is. And then also showing the relation between the words in a sentence. So the main idea is if a stranger came to you and said a specific, and said a sentence to you, what is the probability that, for example, this is my CSVTF was the sentence that the person said? So obviously some sentences are more common than others. For example, good morning, a good night, or hey there. It's much more common than most sentences that we have in English. So why are those sentences more frequent? First of all, it's because you have words that are more frequent. So for example, if you say, the dog is big and the dog is gigantic, usually probably here the dog is big more often because big is more frequent in English than gigantic. So one of the things is the word frequency. The second thing, which is really important, is just the order of the words. So it is common to say the cat is inside the box, but you don't usually see the box inside is the cat. So you see that there is some importance in the order of the words. You cannot just say that those two sentences have the same probability just because they have the same words. You actually have to care about the order as well. Make sense? So what do we do so what am I trying to get you? I'm trying to get you what we call the Engram models. So Engram models basically assume that for each word that you have in a sentence, it's the probability of having that word there depends not only on the frequency of that word in the language, but also on the words that are surrounding it. So for example, usually when you see something like on or at, you're probably going to see a noun after it, right? Because you have a preposition, usually takes a noun after it. Or if you have a verb that is like transitive, you're usually going to have like a noun phrase, so it's going to have a noun somewhere around it. So basically what it does is that it considers the probability of having like words next to each other when you're like calculating like the probability of a sentence. And that's what a language model is basically. It's just like seeing how, what is the probability of having a specific sentence in a language. So why is that useful basically? And first of all, what is an Engram model then? So an Engram model means that each word depends on the next n minus 1 words. So basically means that if I look, for example, at the CSTTF, when I'm calculating the probability of the sentence, you'll be like the probability of having the word the times the probability of having the CS50 times the probability of having the CSTTF. So basically, like I count like all possible like ways of stretching it. And then usually when you're doing this as in a project, you put n to be like a low value. So usually you have like bigrams or trigrams so that they are like, you just count like 2 words, like a group of 2 words or like 3 words just for performance issues. And also because maybe if you have like something like the CSTF, when you have TF, it's like very important that CS50 is next to it, right? Like those 2 things are like usually next to each other. If you think of like TF, it's probably going to have like what class it's TFing for. Also it's really important for CS50TF. But if you have something like the CS50TF went to class and gave their students some candy, like candy and the have no relation really, right? They're so distant from each other that it doesn't really matter like what words you have. So by doing like a bigram or a trigram, it just means that you're like limiting yourself to some words that are around. Make sense? So when you want to do segmentation, basically what you want to do is see what are all the possible ways that you can segment this sentence such that you see what is the probability of each of those sentences existing in the language. So what you do is like, well, let me try to put a space here. So you put a space there, and you see what is the probability of that sentence. Then you are like, okay, maybe that was not that good, so I put a space there and a space there. And then you calculate the probability now, and you see that it's a higher probability. So this is an algorithm called the Tangle segmentation algorithm, which is actually something that will be really cool for a project, which basically takes unsegmented text, which can be Japanese or Chinese or maybe like English without spaces, and tries to put spaces between words. And it does that by using a language model and trying to see what is the highest probability you can get. Okay. So this is segmentation. Now, syntax. So syntax comes like all the way, like it's being used for so many things right now. So for graph search, for Siri, for pretty much any kind of natural language processing you have. So what are the important things about syntax? So sentences in general have what we call constituents, which are like kind of like groups of words that have a function in the sentence and that cannot like really be like apart from each other. So if I say, for example, Lauren loves Milo, I know that Lauren is a constituent, and then loves Milo is also another one, because you cannot say like Lauren Milo loves to like have the same meaning. It's not gonna have the same meaning. Or I cannot say like Milo Lauren loves. Like it doesn't, like not everything has the same meaning. Doing that. So you have the 2 more important things about the syntax are the lexical types, which is basically the function that you have for words by themselves. So you have to know that Lauren and Milo are nouns. Love is a verb. And the second important thing is that there are phrasal types. So you know that loves Milo is actually like a verbal phrase. So when I say Lauren, I know that Lauren's doing something. What is she doing? She's like loving Milo. So like it's a whole thing. But it's its components are like a noun and a verb, but together they make a verb phrase. So what can we actually do with computational linguistics? So if I have something, for example, friends of Allison, I see here, if I just did a syntactic tree, I would know that friends is a noun phrase, it is a noun, and then of Allison is a prepositional phrase in which of is a preposition and Allison is a noun. What I could do is teach my computer that when I have a noun phrase 1 and then a prepositional phrase, so in this case, friends and then of Milo, I know that this means that NP2, the second one, owns NP1. So I can kind of like create some kind of relation, some kind of like function for it. So like whenever I see this structure, which matches exactly with friends of Allison, I know that Allison owns the friends. So the friends are like something that Allison has. Make sense? So this is basically what graph search does. It just creates rules for a lot of things. So friends of Allison, my friends who live in Cambridge, my friends who go to Harvard, creates rules for all of those things. Now machine translation. So machine translation is also something statistical. And actually, if you get involved in computational linguistics, a lot of your stuff is going to be statistics. So as I was doing the example with like a lot of probabilities that I was calculating, and then you get to like this very small number that is like the final probability, and that's what gives you the answer. Machine translation like also uses like a statistical model. And if you want to like think of like a statistical, machine translation in like the simplest possible way, what you can think is just translate word by word, right? If you're like, when you're like learning a language for the first time, that's usually what you do, right? If you want to like translate your a sentence in your language to the language you're learning, you usually first like translate each of the words individually, and then you try to put the words into place. So if I wanted to like translate this, o gato branco fugiu, which means the white cat ran away. If I wanted to translate it from Portuguese to English, what I could do is first, I just translate word by word. So o is the cat, gato cat, branco white, and then fugiu is ran away. So then I have all the words here, but they're not in order. It's like the cat white ran away, which is ungrammatical. So then I can have a second step, which is going to be finding the ideal position for each of the words. So I know that I actually want to have white cat instead of cat white. So what I can do is, like the most naive method would be to create all the possible permutations of words, like of positions, and then see which one has the highest probability according to my language model. And then when I find that one that has the highest probability, which is probably the white cat ran away, that's my translation. And that's like how, like, this is like a simple way of explaining how a lot of machine translation algorithms work. Does that make sense? There's also something really exciting that you guys can like maybe explore for a final project. Yeah?
But you said it was the naive way, so what's like the non-naive way?
The non-naive way. Okay. So the first thing that is bad about this method is that I just translated words word by word. But sometimes you have words that can have multiple translations. I don't know, let me try to think of something. For example, manga in Portuguese can either be mango or sleeve. So like when you're trying to translate word by word, it might be giving you something that makes no sense. So you actually want to look at all the possible translations of the words and see, first of all, what is like the order, like we're like talking about like permutating the things to like see all the possible orders and choose the one with the highest probability. You can also choose all the possible translations for each word and then see combined with the permutations which one has the highest probability. Plus, you can also look at not only words, but phrases. So you can like analyze the relations between the words and then get a better translation. Also something else, which is, so like this semester I'm actually doing research in Chinese-English machine translation. So translating from Chinese into English. And something we do is besides using a statistical model, which is just seeing the probabilities of seeing like some position in a sentence, I am actually also adding some syntax to my model, saying, oh, if I see this kind of construction, this is what I want to change it to when I translate. So you can also add some kind of element of syntax to make the translation more efficient and more precise. Okay, so how can you get started if you want to do something in computational linguistics? First, you choose a project that involves language. So there's so many out there. There's so many things you can do. And then you can think of a model that you can use. Usually that means by like thinking of assumptions as like, oh, when I was like thinking of the lyrics, I was like, well, if I want to figure out who wrote this, I probably want to look at the words the person used and see who like uses that word very often. So try to make assumptions and try to think of models. And then you can also search online for like the kind of problem that you have, and it's going to suggest you like models that maybe model that thing well. And also you can always email me at me@freitas.com, and I can just answer your questions about like we can like even like meet up, so like I can give suggestions on ways of implementing your project. And I mean, if you get involved with computational linguistics, it's going to be great. Like you're going to see there's so much potential, and the industry wants to hire you so bad because of that. So yeah, I hope you guys enjoyed this. If you guys have any questions, you can ask me after this. But thank you.